Okay, in this related rates problem, you'll see that your volume function is given to you. It will be provided for you on your test as well. So my formula is V equals 4/3 pi r cubed. In a related rates problem, we're taking the derivative with respect to t. So this would be dv dt equals 4 pi r squared dr dt. Reading through the problem, and working it out for that matter, here are the three unknowns that I'm going to need. It says the balloon is inflated at a rate, okay, so that's either dv dt or dr dt because it said rate. You'll notice that it gave it in cubic centimeters. Volume is measured in cubic units, so the 300 is going to be your dv dt. It also asks you in the second sentence, how fast, or the second line, how fast is the radius increasing? That's your unknown. I don't know how fast the radius is increasing. It tells you that the radius is 70. So when we put those in there, we have 300 equals 4 pi 70 squared dr dt. Keep your pi as pi. To get dr dt by itself, we'll divide both sides by this amount. 4 times 4,900 is 19600 pi. When you write it, be very careful that the pi stays on the bottom. You'll say, where'd you get the 19,600? If you multiplied 4,900 times 4, you get 19,600. Okay, so when you get ready to work this one here, the 19,600 pi cancels out. You can reduce this. And so what you're going to get is 3 over 196 pi equals dr dt. And that's how it would work. Okay, so here's our next one. A ladder 20 feet long is leaning against the wall of a house. The base of the ladder is pulled away from the wall. We'll call that x. The top of the ladder is dropping. You'll notice it tells you to use the Pythagorean theorem, c squared equals a squared plus b squared. I prefer x's and y's, but the formula that we're going to use is x squared plus y squared equals 20 squared. So x squared plus y squared equals 400. Now when we get ready to take the derivative, we're going to have 2x dx dt plus 2y dy dt equals 0. The derivative of 400 is 0. So when we come to the side, we're going to need an x, we're going to need a dx dt, we're going to need a y, and we're going to need a dy dt. When we read through there, it says the base of the ladder. Okay, here's the base of the ladder. The base of the ladder is being pulled out at a rate. Okay, so I know a rate is a dt variable, and since the base is being pulled out, that's going to be the x variable, so dx dt is 2. The question says, how fast is the top of the ladder moving down the wall? Okay, here's the top of the ladder. It's moving down the wall, and it says how fast. That's a rate. So the dy dt is what I do not know. Continuing through the problem, it says the base is 13 feet from the wall. Okay, here's your base again in the red dot. That base is 13 feet. That means x is 13 feet. But we still have to find y. So, as I've been telling you most of the semester, to find y, use the original. I have to find y before I can find dy dt. So the original is x squared plus y squared equals 400. X is 13. So 13 squared plus y squared equals 400. When you solve that out, you're going to get a value that y equals 15.2. It wasn't an even number this time, but we get it to be 15.2. Now then, all of my unknowns are there except the one I need solving for. So let's plug in what we know. 2 times 13 times 2 plus 2 times y, which is 15.2, dy dt equals 0. Thirteen times 4 is 52. So dy dt equals negative 52 over 30.4. And if you divided that out, you got a negative 1.71. So this would be your answer. Now you'll see up there an answer of 1.71. I'm not going to trick you with that. They tricked you with this during the semester in the My Math Lab homework. So positive 1.71 won't be an option there, but it is falling. And since the ladder is falling, its derivative or its rate should be negative. And that's how we would do that one.